Okay, hi guys. We're going to be working on solving equations using quadratic techniques of like factoring and quadratic formula. And so it'll seem familiar, but it's going to be a little slightly different. Oh, we're also going to be using the zero product property after we've factored. So so we're going to first write expressions in quadratic form. So we're going to practice that first. And not all expressions can be written in quadratic form, so we'll see kind of a pattern. And then once we are able to write an equation or an expression in quadratic form, then we can use those quadratic techniques to solve. All right, so here we go. We're going to practice the first objective first to begin with. So, like I said, some polynomials can be solved. Sorry, not solving, using quadratic techniques like factoring and quadratic formula, if they can be rewritten in the standard form of ax squared plus bx plus c equals 0 usually. So how do we know if we can rewrite an expression in quadratic form? So we have 2x to the 6th plus x to the 3rd plus 9. Now notice, obviously, that the higher degree would be your x squared. This would be your x squared, and then the lower degree would be your x. Is it possible to rewrite this expression in this form of ax squared plus bx plus c? Well, the c is obvious. That's 9. Now, how is it possible to rewrite this expression in quadratic form? Well, in this case, if you notice, I always look at up here on the standard form, x to the first power, x squared. If, and this is usually generally true, if the exponent of what we would consider your linear term is half of the exponent of your quadratic term, so 1 is half of 2, then yes, is 3, so over here is 3 half of 6. Yes, it is. So if we let, usually I write it the other way. So x to the 3rd is going to be considered our x, okay? So this is our x term. This is our linear term. So if that is our linear term, and we just pretend that's our x to the 3rd power is our x to the first power, x to the 3rd power squared. Is that still x to the 6th? Yes, because power rule, 3 times 2 is 6. So all we're doing is writing it in a simpler, and kind of a simpler way with a squared term and a quadratic term and a linear term. All right. Now, number 2 is a little tricky because this is considered our quadratic term and the linear term is 0. So if the linear term is kind of like, I'll go up here. Let's say we have 7x squared plus 6. Well, yeah, that's quadratic, isn't it? Is there any way to rewrite 7x to the 10th as a quadratic? So is 10 divisible by 2? Basically, if you notice that 6 divided by 2 is 3, and that's your linear term. So 10 divided by 2 is 5, so yes, we can, because x to the 5th is going to be our x. So 7x to the 5th squared is 7x to the 10th, plus your constant. On number 3, this would be your quadratic term, and this would be your linear term. So unfortunately, there's no way, if this is your x, if x to the 3rd is your x, if we square that, we don't get x to the 4th. So that's going to be no. That's not possible. All right? And then how about this one? We have, we have rational exponents. So again, just look, is x to the 1/3, is 1/3 half of 2/3? It is actually. So if we let x be x to the 1/3, or let x to the 1/3 be our x to the 1/3 is your x to the 1/3 squared is x to the 2/3 power. So yes, so I know that's kind of confusing, and it's new. So hopefully you'll get the hang of it as we work through these equations. Now, if it says to solve the equation, that means all of these equations can be rewritten in quadratic form. So I'm going to help you out here. The first one, x to the 4th minus 3x squared plus 36. We're going to solve for x, and it's a 4th degree polynomial function, so that means we have at most 4 real roots. So we're going to let we're going to define x squared as our x, because that's our linear term right there, okay? So we're going to define x squared to be our x, and we're going to rewrite in quadratic form. Sorry, that's really sloppy. We're going to rewrite in quadratic form. Okay, so if x squared is our x squared to the second power, that's still x to the fourth, minus 13 x squared is our x, plus 36. And you should notice that this is factorable. These should all be factorable or use the quadratic formula. Just remember that it's not x equals, it would be in this case x squared equals, okay? So now we can factor this. What factors of 36 add to negative 13? That would be negative 9 and negative 4. So the factors are not x and x, it's x squared minus 9 and x squared minus 4. Right? Now, if you notice, keep factoring. Factor both factors of difference of squares. Because x squared minus 9 is factorable into x plus 3 and x minus 3. And x squared minus 4 is x plus 2 and x minus 2. And so now we've fully factored, and now we can use the zero product property and solve. All right. Running out of space. We have x plus 3 equals 0, x minus 3 equals 0, x plus 2 equals 0, x minus 2 equals 0. And just quickly add and subtract 3, add and subtract 2. And I'm going to write it in red over here. X equals plus and minus 3, plus and minus 2. We have 4 real roots, which it's a fourth degree polynomial function, so at most we could have 4 real roots. All right, here we go. The next one. Every example is different, so you make sure you include all the examples today. X to the third plus 343. Now, you can't write this in quadratic form. So, because we don't have let x be something and square to be cubed. So it doesn't work that way, but did you notice it's a sum of cubes? Sum of cubes. So we're going to factor it as a sum of cubes. And so it's a sum of cubes. Just got to remember your cubes, your perfect cubes. Do you remember SOAP? Helps you factor. The first factor sign, it goes same sign, opposite sign, always positive sign. So the first factor of x cubed plus 343 is the cube root of x cubed, which is x, and the cube root of 343 is 7. So x plus 7 is the first factor. The second factor is the quadratic, and we square this x, so that's x squared. And so it's the same sign, opposite sign. And then the next term is the product of x and 7, so that's 7x. So same sign, opposite sign, always positive sign. And the final term of the quadratic is the 7 squared, which is 49. So that should be coming back to you because you have learned that. So sum of cubes, factor, sum of cubes. The first factor is always the cube root linear factor, and the second factor is the quadratic that is not factorable, okay? Oops, I forgot my equals 0 here. So now we're going to use the zero product property. And solve. Okay, so I have x plus 7 equals 0. And I have x squared minus 7x plus 49 equals 0. Now, x plus 7 equals 0, x equals negative 7. There's one of my answers, okay? The other equation is a quadratic. It is not factorable, so I'm going to write in red, not factorable. So you could use completing the square, which unfortunately the linear term is odd, so I don't really want to go that direction. I don't want to try to divide 7 by 2 square and work with fractions. So I'm going to use the quadratic formula. Oops, I spelled that wrong. Quadratic formula. All right, so if it's not factorable, use the quadratic formula. So x equals negative b plus and minus the square root of b squared minus 4 times a, which is 1, times c over 2a. All right, and so we've got negative 7 is 7, plus and minus the square root of 49 minus 4 times 49 is actually 196, divided by 2 times 1, which is 2. That's going to be imaginary. So we've got 7 plus and minus the square root of negative 147, I believe, over 2. And that is simplified. You got to make sure you simplify that radical. And so, let me just get some space down here. X, we have 2 roots so far. We have x equals 7. I'm going to use red so you can see that. So we have x equals 7. Or sorry, negative 7, excuse me, negative 7. And then we also have the complex roots of 7 plus and minus 7i root 3. That's what that simplifies to, over 2. And so we have 1 real, negative 7, and 2 complex, 7 plus and minus 7i root 3 over 2. And remember, this was cubic, so we have 3 roots total, 1 real, 2 complex. And that's really kind of important to note. So you have 1 real, 2 complex. Up here we had 4 real. So always checking the degree against how many roots. So fourth degree, we have 4 roots. 3rd degree, we have 3 roots. All right. This is an interesting one, the square root of x. If we square the square root of x, we get x. So yes, that can be written in quadratic form. So we're gonna let x, we're gonna let the root of x be our x, okay? Oops, there we go. So we're gonna define our x as the square root of x. So we have the square root of x squared. And remember, the square root of x squared is x. So yes, that works. Minus 6 times this square root of x minus 7 equals 0. That is factorable. And so we've got the square root of x minus 7 and the square root of x plus 1. All right, now we're going to use the zero product property. So we have the square root of x minus 7 equals 0, the square root of x plus 1 equals 0, and, oops, I forgot and solve. Okay, so here's the deal. I am going to use this space over here. So I have the square root of x, add the 7 over, equals 7, all right? And I have the square root of x equals negative 1. I'm going to square, and x equals 49. Okay, now, however, the square root of x can't be equal to negative 1, can't be equal to negative 1, because remember, the principal root can't be negative. So this factor has no solution, so no, not solvable. So there's only one solution, it's x equals 49. So be careful with the square root of x, all right? So that is key right here, this guy right here. Can't be equal to a negative. Okay, okay, number 4 looks familiar from when we were talking about writing in quadratic form. 1/3 is half of 2/3, so we're gonna let, I'll use green now, so let x to the 1/3 equal your x. Let that be your x, okay? So x to the 1/3 squared is still x to the 2/3, very good, minus 6, x to the 1/3 plus 5, and we're gonna factor. Okay, so we have x to the 1/3, let's see, factors of 5 that add to negative 6, that would be both negative 5 and negative 1, wouldn't they? x to the 1/3 minus 1. And we're going to use the zero product property. Product property and solve. So we've got x to the 1/3 minus 5 equals 0. X to the 1/3 minus 1 equals 0. We're going to add 5 over and add 1 over. So x to the 1/3 equals 5. X to the 1/3 equals 1. How do we undo the 1/3 power? Remember, that's the cube root of x. So if we raise by a power of 3, that will cancel that out, okay? So x is going to be equal to 5 to the 3rd power, which is 125. And we're going to cube and cube, and those cancel out if we're out to do that. And x equals 1 to the 3rd power, which is, oops, sorry. So x equals 125 and 1. All right, hopefully you're catching on. We've got one more to do together, and then the final one is your turn. So x to the 4th equals 49. Well, always got to be equal to 0, so that's the first thing is subtract, that's a to the 4th, not x, sorry, over. Now, can we write this in quadratic form? Yes, because even though the linear term is missing, a squared to the 2nd is a to the 4th minus 49 equals 0. You're going to let, sorry, a squared be your a. And now you should notice that that's a difference of squares. So we have a squared plus 7 and a squared minus 7. So we're going to factor. And now you're going to use that zero product property again over and over. And so now I have a squared plus 7 equals 0, a squared minus 7 equals 0, and now we solve. Okay, I'm going to go up here because I ran out of space. So a squared equals negative 7, a squared equals positive 7. To undo a square, we take the square root. And hopefully you notice that we have, when we're taking the square root of a variable, you have the plus and minus, I forgot that. And so a equals plus and minus I root 7, because that's negative root of 7, and plus and minus root 7. So we have 4 roots. We have 2 real and 2 complex. All right. Okay, last one. Go ahead and pause. And like I said, all examples have been different so far. So this one's a little different for you. Go ahead and try it. Okay, so you're going to start off with defining your x. So let x to the 1/4 be your x, okay? And so after you define, you're going to write in quadratic form. So x to the 1/4 squared is x to the 2/4, which is x to the 1/2. Good. Minus x to the 1/4 minus 6. And for this one, whoops, I forgot my parenthesis there. It is factorable. So what factors of negative 6 add to negative 1? So yeah, that would be negative 3 and positive 2. So we have x to the 1/4 minus 3 and x to the 1/4 plus 2. So after we do that, we factor. And now we're going to use the zero product property. I'm just going to go up here because I ran out of space. So x to the 1/4 minus 3 equals 0. X to the 1/4 plus 2 equals 0. We're going to add 3 over. Oops, that's a 4. And subtract 2 over. And so on this one, where you raise to the 4th power, raise to the 4th power, and x equals 3 to the 4th power, which is 81. But over here, remember, this is a even root. So you can't have even roots equal to a negative. So that can't happen because it's an even root. Even root can't equal negative. Because again, we want that principal root. So I don't know if you caught that. It's kind of tricky. So the only answer is x equals 81. Okay, I hope you come prepared with some questions. The factoring part's pretty easy. Just got to remember your factoring skills. The defining of what your variable is to write it in quadratic form, that can be a little tricky, and that's the new part that is a little harder. But please don't hesitate to ask, and I'm happy to help you.